In this video, we will see how to detect if a linked list is having a loop or a linked list is linear. So what is a loop? I'll explain first. See, there is a linked list and the last node of a linked list is pointing on some node in a linked list. It's not the first node, it is some other node. So if a last node is pointing on some node of a linked list, then it is forming a loop. So this linked list is having a loop. Then I have one more linked list which is ending with null. Last node is having null. So this linked list is linear. So there is one linked list with loop and there is one linked list that is linear. Now the problem is, if a linked list is given to us, we have to find out whether it is linear or it is having a loop. How to detect? So first let us see how to detect whether it is linear or not. A linked list will be linear if it is ending with a null. Last node is having null. Now how to know whether the last node is having null or not? So we have to start from first node and reach the last node and check that it is really having null or not. So for that, let us take a pointer P and go on moving upon this one, next, 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 and at one point P becomes null. So if P becomes null means it is linear. So if you are scanning through a linked list or traversing a linked list and the pointer becomes null, means it is linear. Now how to know whether it's having a loop or not? So if I take a pointer P and go on scanning the linked list or traversing a linked list, then P will be moving on to this node, then 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 again it will come to this node, then this will give the address of this one. So it will be moving around these set of nodes only. Then how I should stop and say that this is having a loop? How to know that there is a loop in this linked list? So there are different suggestions like store the addresses of the nodes, and if you come across the same node once again, then there is a loop in this one. Or you can store the elements if the elements are unique. If you are sure that the elements are unique, then if you come across the same element once again, then you can say there is a loop. There is one more method using two pointers. I'll show you that one. See, we will take two pointers on a linked list. One is P and other one is Q. They both start from first node. Then P will move by one step and Q will move by two steps. So I can compare these two pointers with one example. Like suppose there is a race track. So these are two cars on the track. This is the starting point and the track is 15 kilometers, and suppose this car is moving with a 100 kilometer per hour speed and this car is moving by 150 kilometer per hour speed. So this car is very fast. Now from the starting point, when they start off the race, then do you think they will meet again at any place? No, this car is slow, that car is fast, they never meet again. Definitely this will reach first and this will be reaching there slowly. Now instead of having a straight linear track, we can have a circular track also. Suppose this track is of 1 kilometer and these two cars, they have to take laps of this track 15 times. They have to move around this one for 15 times. So if this car is 100 km per hour and this car is 150 km per hour, as they are going to make 15 rounds of this one, then definitely they will meet at one point. So it means if one car is slow, one car is fast, they never meet if the track is linear. They will meet once again if the track is circular. So same way, if the linked list is having a loop, then these two pointers will meet. If it is linear, they never meet. So let us apply the same idea upon the pointers. One pointer will move it slowly by one node and one pointer will move it fast by two nodes. So I have P and Q. So let us move P by one node and Q by two nodes, 1, 2. So Q is here. Then move P by one node and Q by two nodes, 1, 2. So Q is here. Then move P by just one node. Then move Q by two nodes, 1, 2. So Q is here. Then move P by one node. Move Q by two nodes, 1, 2. So they are meeting again. So if the 2 pointers are meeting again after the starting point, if they meet once again, then there is a loop. Let us apply the same thing there. I have P and Q here. Now let us move P by 1 node and Q by 2 nodes. Then P by 1 node and Q by 2 nodes. 1, 2. So in the next step, Q becomes null. So if any one pointer becomes null, we should stop and say that this linked list is linear. So in a linear linked list, one of the pointer will become null. Definitely Q will become null because it is moving faster. So we can take 2 pointers and find out whether it is having a loop or it is linear. If they meet again, then there is a loop. If one of the pointer becomes null, then they are linear. Now let me write down the function for checking whether there is a loop or not. If no loop means it's linear. I'll write a function. Let us call the function as isLoop. So this will return true if there is a loop. If it is linear, it will return false. So this takes a pointer to the first node. This is f. Then it is going to return true or false, so it is integer type. Now we need 2 pointers, node P and Q. 2 pointers are needed, and P and Q both are on first. This is f. F is for first. I am calling it as first. First we will be passing it as parameter. Now what they have to do? So using do while, just move P by 1 step and move Q by 2 steps. So Q assign Q's next. This is the first step. And second step, don't take it blindly. If Q already became null, then there is no next node. So check if it has become null. If it is not null, then move to the next. So if Q is not equal to null, then Q should be assigned with Q's next. Otherwise, let Q be null only. Now here inside while, I will write on the condition that while P and Q continue as long as both the pointers are not null. Both the pointers are not null. Now at the end of this, there is no space, so I will continue here. If P is equal to null, means both are at same place, then return true. True. I am writing true here. True means 1. I will be returning 1. If they are not equal, means definitely one of the pointer is null. So return false, means it is not having loop. Not having loop means definitely it is a linear linked list. So this is the code. So there is no space, so I continued here, just conditional statement. I can write down that condition here also. I can say simply return if P is equals to Q, return true, else return false. Suppose true means once and false means 0. So function ends here. So that all that conditional statement if else I have written in just one single line. Return if P is equal to Q, return true. Otherwise return false. So this is the procedure for finding whether there is a loop or not. So analysis. How many pointers required? 2 pointers. What's the time taken? Order of n. That depends on the number of nodes. So this scanning is done depends on the number of nodes. They may be scanning the portion of a loop more than one time. That doesn't make much difference. Even we can say 3 times of n also, it is order of n. So it is multiple of n, that is number of nodes. So it's not n times of n, so to call it as n square, some number of times of n. So we can call the time as order of n. So that's all about this procedure.